these are the last two problems I will cover from 7.1. So let's look at 47. Okay, we have our function x times e to the negative x squared. If you plug in your calculator, it'll have this graph here. Y equals 0, that is the x-axis. And we are given the interval from 0 to 1. So from 0 to 1, so we're looking at finding the area of that shaded region. Okay, so we can simply do top minus bottom because this curve is always going to be above the axis and it's going to be consistent from our left to our right bound. So we can just plug in our formula here. So area will be from our left bound to right bound, so 0 to 1, which is given to us. And our top curve is xe to the negative x squared, and our bottom curve will be 0. So we're simply finding the definite integral of xe to the negative x squared from 0 to 1. So if we look at this, we can think about the rules that we've learned to evaluate. So this is in the form of e to the u. So we have to go through u substitution. Our u value is negative x squared. Our derivative is negative 2x. Solve for dx, we get du over negative 2x. Plug in and start making our substitutions. The x will stay. We have e to the u, negative x squared gets replaced with u. Dx gets replaced with du over negative 2x. The x is canceled out. We pull the negative 2 as a coefficient, a negative 1/2. And then the integral of e to the u will remain e to the u. Now, our bounds are in terms of x. Because we're going through u substitution, we're going to have to convert our bounds to be in terms of u so that we can plug in using the correct variable. So we convert using the assigned value for u, which is the relationship is u equals negative x squared. So we plug 0 in for x, and negative 0 squared will remain 0, so the lower bound is not going to change. We can plug 1 into the in for x, so negative 1 squared will be a negative 1. So our new upper bound is negative 1. Our lower bound will remain as 0. So then we plug negative 1 in for u, so we get negative 1/2 e to the negative 1 minus. Now plug in 0 in for u, which is e to the 0. So this reduces to be negative 1 over 2e. And I've got to be careful here. E to the 0 is not 0. E to the 0 is 1. So 1 times negative 1/2 times negative 1 is positive 1/2. So we can use our calculator to combine to be 0.316. Okay, number 71 just says we're given the graph of x to the 4th minus 2x squared plus 1, which is this quartic function that you see here, and the y equals 1 minus x squared, which you see here with the parabola that opens down. The problem says that this can be found by using a single integral. And the reason why is because even though these are split into two regions, we can write this as one integral, because the upper function, which in this case is the 1 minus x squared, does not alternate. So it remains the top curve on the left, and it also remains the top curve on the right. So since 1 minus x squared is always the top curve, it's always above this x to the 4th minus 2x squared plus 1 between this interval that we see. We can therefore write it as one integral and no need to split into two integrals. So to find the two intervals here, or actually three because there's one here as well, we set the two equations equal to each other, bring everything over to the left, factor out the x squared, and we get x equals 0, 1, and negative 1. Okay, so we can simply write this as one integral from negative 1 to 1. We can totally skip the fact that we have a 0 there because we've determined that we're going to have the same consistent upper bound all the way throughout. So the top curve is the 1 minus x squared, the parabola, and the bottom curve is the x to the 4th minus x 2x squared plus 1. So we combine this to be combine this to be negative x to the fourth plus x squared. Go through our power rule, x cubed over 3. X and negative x to the fourth becomes x to the fifth over 5. Okay. Evaluate between our upper and lower bound. So plug 1 in for the x's. We get 1/3 minus 1/5. Minus, now we plug the lower bound. We get negative 1/3 plus 1/5. And this combines to be 2/3 minus 2/5, which is 4/15.